Good evening, one and all present here. We Ponpure Chemical Groups happy to welcome you all to this webinar on static electricity. I would like to welcome our respectable host for this webinar, Mr. Sridhar, Safety Head of Ponpure Chemical Groups, serving for more than 26 years. Happy to welcome you once again, all. Sir, handing over to you.
Thank you, Divya. This is Sridhar, Safety Head of Ponpure Chemicals Group. Now, we are discussing about static electricity. What is static electricity? Effect of static electricity on solvents. Then, how to dissipate the static electricity using bonding and grounding. Okay, we will go to the program. What is electricity? First, before going to discuss about static electricity, first we will see the electricity. What is electricity? Electricity is nothing but movement of electrons, that is negatively charged particles, called electricity. In electricity, that protons and neutrons present in atom, the protons and neutrons are present in the center of the atom. The electrons which is moving around the orbital, that is outer surface of the atom, is in electron. That electrons always in motion. This is called electricity. The motion of electrons is called electricity. First you can understand the electricity, then only we can easily understand what is static electricity. Then we will go to static electricity. Static electricity occurs when there is a buildup of electrical charge on the surface of the material. When the charge will be built up while rubbing to each other, that is, one stationary phase is there, that moving phase is rubbing the surface, so that the separation of charge will be taking place. After separation of charge, the accumulation of charge is also taking place. This phenomenon is called static electricity. The static electricity is a stationary charge. That in electricity, the charge is moving, that is, moving of electron is called electricity. Here the separation of charge, that charge also not in motion, it is stationary, so this is called static electricity. The electricity we use in everyday involves moving of charge. Now the examples. First we will see the examples for the static electricity. Normally in balloon, we rub the balloon in the head and we leave the balloon, means it will attract towards the wall. This is due to the charge, the stationary charge it will generate during this process. How we got the electric shock? Then normally these are all the examples for the static electricity. Have you ever got the electric shock of your doorknob while fastly you are walking, then you are touching the knob? Sometimes the charge, the slight electric charge you can notice on your fingers. This is also due to static electricity. Have you ever seen lightning? Lightning is one of the example for the static electricity. Normally these are all the few examples we see in the day-to-day life. In pictorial representation, I will tell you how the charges are separated and accumulated due to electricity, static electricity. In this picture, you can easily notice that the two, one is stationary phase, that yellow color is stationary phase, that blue color is moving phase. Normally, while rubbing the surface, the charge is always remains in the surface, that due to the rubbing of moving phase, the charge will be separated. That negatively charge is separated one side, negatively charge separated due to the rubbing. That is, only this static electricity is a phenomenon of separation of charges on the surface of the chemical as well as the lines, that is pipeline or very stationary phase. In this picture you can easily understand that is how the charges are separated. The effect of static charge. In solvents, we have the tendency to, solvents normally have the tendency to form a flammable vapor easily with the atmospheric air in normal temperature, that is atmospheric temperature. These is the properties of solvent. Normally, all solvents develop static charge due to this friction. That is one more thing. Before going to understand the static charge, we need to see the flash point. What is flash point? Flash point is the minimum temperature in which the flammable chemicals, that is most of the solvent are flammable in nature. These flammable chemicals form a flammable mixture with atmospheric air and catch fire when the fire sources exist. When fire sources exist, then only it will catch fire. This static charge acts as an indirect fire source to catch fire. So we need to pay more attention during the solvent handling. While handling the solvent, transferring the solvent and transferring the solvent from one place to another place, we are using pumps and pipelines. So we need to take extra care on static charge. Okay, then one more concept we need to understand, that what is LEL and UEL, that is LFL and UFL, that is lower flammable limit and upper flammable limit. This is nothing but LEL, LFL is similar to LEL, that is lower explosive limit, higher explosive limit. This is in this diagram we can see that acetone vapors 2.5% concentration itself, it can catch fire. That is called LEL, lower explosive limit. Then higher explosive limit, that is in acetone 12.8% is 12.8% is the concentration, higher concentration. What it denotes, that is below the LEL, that vapors cannot catch fire even though fire source exists. So that chemical will form a flammable mixture within this range, that is in between the LEL and UEL only. That chemical forms a flammable mixture with atmospheric air, then only it will catch fire. So below the LEL there is a mixture having low flammable vapor concentration, that is more the mixture having rich in oxygen but vapor concentration is less. So below the LEL there won't be any fire, even though static charge is there won't be catch any fire. After the UEL, the mixture contains more chemical vapor concentration, that oxygen percentage is less. So this stage also fire will not happen, even though charges exist, that is heat is exist or fire is exist. The only the flammable range is in between the LEL and UEL. So in order to consider this, that a fire triangle, first we will see the fire triangle. In this fire triangle, that is three components is required to catch fire. One is fuel, another one is air, that is oxygen in the air, another one is heat source. If three components combine together, then only it will catch fire. In this case, that static charge acts as an indirect fire source. So in chemical industries, they are doing more activity with the solvents. During this activity, that solvent vapors always present in the atmosphere. So in order to avoid that heat source, we need to little bit careful in static charge. That static charge plays major role for indirect fire source. These are all the few examples that solvents used in the industry. that flash point range, that is lower explosive limit, higher explosive limit, and flash point. The auto ignition temperature. These are all the things given in this. Normally we are using in our day-to-day life. These solvents are used in the chemical industry. This is a value given in this. So the flammable range is in between the LEL and UEL. Then effects of static charge. Static electricity is produced in industry. Normally we are having different application, that is we are mixing the solvent with another solvent, we are dissolving some salt in the solvents. Due to the industry application, that usage of solvent is more. So we, in this case, how we can avoid static electricity? First, how the static electricity is produced in solvent we will see. Then how we can eliminate the static charge, that we will see later. First, the static electricity is produced by pumping of material by any other means of motion, such as agitation. When you are mixing the two liquids, that is two solvents, we are going to use agitator. During the agitation also, the charge separation will take place due to static charge. When the movement separates the electric charge, which accumulate on the liquid surface, that is solvent surface, it will be stagnated in the system. The lines or tanks, there is a static charge accumulation. The charge on the containment system is dissipated quickly by providing earthing, but the charge in the liquid remains in the liquid itself, and it is slowly dissipated depending on the conductivity of the liquid. So the conductivity of the liquid also plays major role in this static charge. So we need to understand what are all the liquids having conductive, that it is conductive liquid, what are all the liquids are conductive liquids, and what are all the liquids are non-conductive liquid, what are all the liquids are insulating liquid, that we will see now. That affect the static charge. This is the pipeline transfer. The chemical is transferred through the pipeline. So how the charge is separated, you can easily see in this diagram. The charge is developing on the surface of the metal surface as well as the liquid surface. So this is the charge separation due to motion of the stationary, that is motion of the liquid with the line. That is liquid phase is stationary phase, the line is fixed phase. The line is stationary phase, that this is moving phase, liquid is moving phase. Due to that, friction is developing on the surface of the pipeline. So the charge separation is also takes place at the surface. Then you can see that some conductivities, some chemicals conductivities is mentioned here, that methanol is having this much of conductivity. Higher conductivity, that liquid easily transfer the electron, that is transfer the charges from the system to surroundings. So it can easily, the charge can be easily dissipated. So that hexane, pentane, xylene, these are all having very low conductivity. So these liquids, the charge is generated, charge is stored, accumulated. This charge, accumulated charge, has to be safely grounded. That is safely, it has to be grounded. Otherwise, it will catch fire. So we need to select conductive liquid for our operation. If you are going to do any operation with a non-conductive liquid, you need to pay extra care. That is more care to be taken while dissipating charges. The conductivity, based on the conductivity, the liquid is separated into 3 stages. That is conductive liquid. More than 10,000 PS per minute is called conductive liquid. Semiconductive liquid, the 100 to 10,000, it is called semiconductive liquid. Non-conductive liquid, less than 100, is called non-conductive liquid. So if you are working with non-conductive liquids, we need to pay more attention on static charge. That how the static charge generated, how the static charge is accumulated, how the static charge is dissipated, discharged. That we will see. The generation, it is a temporary charge generated on the surface due to the friction of two different materials are placed in contact. The exchange of charges occur between them. This is called charge generation. How the charge is accumulated? Unless until the material are conductive, the electrically bonded together, when the surface are separated, each acquires the equal and opposite net charge. The net charge drain away to the ground, the rate that depends on the conductivity of the material. So that material we need to select conductive material. If it is not conductive material, we need to ground the generated charges effectively. Then only we can avoid fire in this operation. The electrical charge may be built up on the underground conductive material. Ungrounded conductive material. Ungrounded conductive material means that material, such metals, non-conductive material, most plastic, that is, that electric charge may be built up due to non-conductive nature of the container or vessel or any material used for this operation. So plastic is non-conductive in nature, so that dissipation of charge will be less. So due to external aid, any additional SS rod has to be placed to bring the charge to the ground. That is effective grounding method, that is called. This is in schematic diagram. We can see that pipeline transfer of chemical, that solvent is pumped through the chemical through the pipelines to the vessel. The charge separation takes place at the surface of the liquid, that is the pipeline, as well as the liquid. So the charge separation in first drawing, it is a charge separation is taking place. The second drawing, the liquid surface, the generation of accumulation of the charges is taking place. How the charge is effectively grounded? By means of providing effective earthing. The earthing has to be given to the vessel, then only we can earth that is ground the charge. In the earth pit, we are in this earth pit, we need to connect this earthing to the earth pit. That ground is simply, we saw that the ground itself, it is conducting the charges. That effective means of connecting through the earth pit, easily the charge will be dissipated. So that we need to provide earth pit separately, exclusively for this static charge. That is earthing should be checked periodically, maintained perfectly, then only that electrons, that is charge, which is generated during this process, will be dissipated properly. Every 6 months once, we need to check the earth pit and check the conductance of the earth pit. We need to check the resistivity of the earth pit. It should be maintained below 1 ohms. Below 1 ohms, the resistivity of the earth pit has to be maintained such a way that then only we can easily dissipate the charge. Next, typical separation process. How the charges get separated. While pouring the powder material from polythene bag to another container, by transferring the pump, transferring the liquid through pumps, and the person walking on the non-conductive floors, and these are all the examples for the charge separation process. In this drawing, while pipeline transfer, how the charge is accumulated. The pipeline is made up of any metals, that is SS or MS material. In these pipelines is connected through the flange joints. In the flange joints, we are placing gasket for the proper tightening and avoid leakages. These gaskets act as a non-conductive material. So any charge is produced during the friction, that is the movement of solvent, that gets accumulated in that part, that is in between the flanges. So in order to transfer, that is, in order to take this charge, we need to provide bonding. That is, that jumping connection has to be given from this side flange to the another side. Then only the charge can be moved. That is transfer and earth. So we need to provide proper bonding for this. The second picture, we can see that charge is developed in the drum due to static charge. Then this charge is not dissipated to ground because that drum is kept on the wooden pallet. Wooden is non-conductive. Above that there is a polythene paper. This is also a non-conductive material. So the charge accumulated inside the barrel itself. If any chance of vapor, solvent vapor present, it will easily catch fire due to jumping. So another example, the STP drums containing the solvents. Already STP drum is insulated material only, it will not transfer the charges to ground. So the accumulation of charge is present inside this. So when vapor, the chemical vapor reaches LEL, it will immediately get fire, catch fire. So in order to avoid this, we need to store the solvents in MS barrel, that is safe. Then the charge which is generated inside has to be grounded properly by external means of inserting any SS rod or any earthing provision given to that rod. We can easily transfer the accumulated charge to the earth pit. This is the another one is that is bodily charge. That is, body is made up of atom. It is also produce charge while fast movement. This charge also to be earthed properly. Otherwise, it will also create problem. Then schematic representation of the steps of the charge separation, accumulation, and explosion hazard due to electrostatic charge and the charge dissipation and ignition. So in the first drawing, how the charge is produced and how the charge is accumulated, it is shown in the first drawing. Then due to this charge, how the fire is happening, that is in second drawing. It is easily noticeable because of this accumulation of charge and also the vapors present in the atmosphere, that is inside the vessel. It is in between the LEL and UEL, so it is ready to catch fire due to this static charge. This is effect of static charge. In this static charge, that is static charge is act as a indirect fire source. Normally the hot surface and fires and flames and smoldering materials and mechanical and electrical generation of spark is also act as a, these are all the direct fire due to this static charge. So we need to pay more attention to the static charge. After generation of static charge, we need to ground it as early as possible. The conductive and non-conductive selection of containers, because that is solvent is always producing static charge, so we need to take very careful for selection of containers. That MS container is easily dissipate the charge. Whatever the charge is accumulated inside, it is easily dissipated. So we need to prefer MS drum for the solvent storage, because that HTP barrels or PP or HTP barrels having the resistivity, because that in this home meter you can see that that is 10 to the power of 8. That conductivity, that ohms is 10 to the power of 8, less than 10 to the power of 8. The resistivity is less than 10 to the power of 8 is a conductive. More than this, it is not safer for storing the solvent. So nowadays there is a anti-static additives are available in the market. So during the manufacturing of STP barrels, that some anti-static additives can be added. It can improve the conductivity of that material. That is also a not a permanent solution. That is for a shorter period only the conductivity will be developed in the STP container. Better you can use metal drums for the solvent handling. Then we need to the static charge, generation of static charge is directly proportional to the velocity of the liquid transfer, that is velocity of the solvent which is transferred. So this, in this table we can easily understand that the safer velocity that can be maintained in order to avoid static electricity. Sudden production of static electricity can be avoided by limiting the velocity. That is the, in first line we can see the pipeline dia, that is pipeline transfer. We are going to transfer the chemical in this pipeline, that the dia of the pipeline is given in the first line, that is 40 mm dia, 50 mm dia, 80 mm dia. This is the diameter of the pipeline. Second one is velocity, velocity of the liquid we are going to transfer, that is the solvent we are going to transfer. In 40 inch dia, 40 mm dia, the velocity should maintain 6 meters per second. That is directly proportional to the quantity of liquid which is pumping. In 40 mm pipeline, we can pump 600 liters per minute. We can maximum we can pump. In 50 mm dia pipeline, we can pump 800 liters per hour. This is the indication for safer transferring of solvent. It can be produce less amount of static charge. Maximize the safety in the area, we need to ensure the following. That is, ensure all the operation and managers are trained in the safe working with flammable product. That is vital that understand the characteristics of dangers of flammable products and the principles of static control. Ensure all the electrical equipment is appropriate for use in the designated flammable atmosphere, because the electrical equipments are more prominent for producing spark. So that in flammable atmosphere, we need to select FLP rated equipments has to be used. That is light. If you are using light in the flammable atmosphere, you need to go for FLP lights. If you are going to use any pumps in the flammable area, we need to go for flammable FLP pump. So any fittings, electrical fittings used in the flammable atmosphere, we need to select flammable pumps, that is the certified pumps, that is flame proof pumps has to be used. Not only pumps, any equipment that has to be certified by the authority, that is government authority, PESO department has to be certified. And some we need to develop some restriction for smokes, that is smoking restricted, static hazard is there. So warning signage boards has to be displayed in that area. Then only we can easily eliminate the static risk. While chemical charging, the fill pipe either extended at the bottom, because that splash filling itself form a static charge. So any filling to the container, it should be extended up to the bottom, then only the charge generation will be less. So it is safer operation. If you are splash filling, that is top from the top of the container we are filling, means the splashing of chemical leads to charge generation. It will also having the risk for charge formation, that is static charge formation. Use low speed stirrer and agitation. Vigorous stirring should be avoided for the solvent. If you are stirring the liquid, that is solvent, very vigorously, that accumulation, that is charge generation will be more, that is also having risk. Do not pour the powders from the insulated bags. That is, if you are charging any powder from the plastic bag, is directly produce static charge. So you need to careful in it, because the charge developed through this powder pouring operation is directly contact with the flammable liquid storage tank, easily catch fire. The limit the velocity of transferring liquid already we saw in the previous slide, and add is anti-static agents to the container, that also already discussed. Inertization, this is one more method, that inertization. If any this reaction, that is any addition or agitation is taking place in the vessel, you need to purge the inert gas. That is, inertization is nothing but adding of nitrogen gas to the atmosphere, that is surface of the liquid. If you are doing this nitrogen addition, that is nitrogen gas addition, the nitrogen is the inert gas that will form a bed on the liquid surface. So anything is happened due to this charge separation or charge accumulation is happened on the surface of the liquid also, it will easily seize the oxygen atmosphere, oxygen present in this atmosphere. Nitrogen is displaced the oxygen. So the formation of three combination of mixture will be avoided. That is heat and fuel and air. The air contact will be removed due to the inertization. So we can safely avoid the fire formation or any incident. The conductive equipment, that conductive equipment means conductive equipment has to be used, otherwise that non-conductive equipment, that bonding and earthing has to be provided. First bonding has to be provided to bring the accumulated charge, then this line has to be grounded, that accumulated charge is easily grounded to the earth through the earth pit. Observe relaxation time 3 minutes after sieving or stirring or solvent, because that charge relaxation time we need to give 3 minutes for any vigorous stirring or any filtering operations. We need to consider minimum 3 minutes we need to give for charge relaxation. That is very most safe operation. We need to give 3 minutes time for the relaxation, and also that we need to do this operation below 5 degree of the chemicals which is used. That is the flash point of the chemical. We need to consider this chemicals flash point below the 5 degree. We need to do the operation. That the chemical flash point is 45 degree. We need to carry out this operation below 5 degree. That is 40 degree. It is safer. Ensure the operations are supplied with the static dissipative gloves to be worn, and also static dissipative pad has to be used while the person is working in that solvent area. That is due to friction, that is due to his body also generates some static charge, so that bodily generated static charge has to be dissipated by touching this person to the anti-static charge dissipative pad, so that bodily charge that has to be dissipated first, then only that person allowed to do the work in that flammable atmosphere. Ensure the floors are adequately conductive and well grounded. Ensure the static dissipative footwears, that is anti-static shoes, has to be used for safer operation, and ensure all the containers, pipeline work, hoses or plant are conductive or static dissipative by means of bonding together. Then the bonded lines or pipelines or anything has to be grounded properly. Ensure that sufficient suitable grounding leads to be clamp to be provided, enable to movable container, then grounded prior to the product transfer. That is, any product or plan to mixing or this thing, we need to provide proper grounding, because some of the containers, that is container is movable container having the PP wheels at the bottom. Due to the PP wheels, the conductivity will not take place from the vessel to the floor. So we need to give proper earthing by means of clamping earthing cable on the vessel. Where the practically that pipeline liquids directly, where the practically the pipeline liquids directly from the storage to the point of use, they eliminate, they minimize the product free fall at the distance. These are all the steps we need to take for minimizing the generation of static charge as well as the accumulation. Then in practical, we are pumping speed is low. That is already told that the velocity of pumping has to be maintained within that limit. The table I already shown that less than that only, that safer velocity, we need to maintain that. Use anti-static additives. For considering low conductive liquid, we are storing any solvent, means we need to add anti-static material. Then only that vessel or container will improve the conductivity. So there is no harm in it. These are all the pictorial representation that how the static charge is developed due to the action, that rubbing action. In first drawing, that is due to rubbing action, that insulated material is rubbed, so that charge separation is taking place. That bottom of the container also having the wooden pallet, it will not dissipate the charge. The drum itself, HDP, it will not transfer the charge. It is unsafe. In this second picture, there is a charging, that is charging from the top of the vessel to the STP barrel. This is also unsafe. It is also create a static charge. So the second safest method is has to be charged the chemical through the MS container, as well as even though splash filling, top filling is there, there is a safety precaution because of earthing has to be provided both the containers, so that accumulated charge is easily earthed. Another, these are all the bonding and earthing connections given for the containers while agitation and transferring. This is the safe method. This is a drawing showing that static charge generation, even though there is a static charge generation, it will be grounded safely due to these connections, that is bonding and earthing. In this picture also you can see that how the liquid is transferred, that top of the vessel also we can transfer by extending the funnel bottom up to the bottom. This is the safest method. In this method, that is generation of charge will be less, so it will avoid the generation of static charge. In the second drawing also, that is directly should not pour. This is unsafe. We need to use this funnel for safer pouring of liquid. Then grounding of drums. The major problem is we need to fix the earthing clamp properly on the surface of the barrel. We need to use proper earthing clamps. Proper earthing clamps leads to easily dissipation of charge will take place. So by fixing the clamp is very important. It has to be fixed properly on the surface of the barrel. The same thing, that continuity of wire, that earthing wire has to be checked properly. It should be, continuity should be maintained till the earth pit. Earth pit conditions also we need to check periodically. Due to that, we can ensure the safe earthing of accumulated charge. These are all some examples how we can provide bonding to the barrel transfer. From one container to another container, we are going to transfer the solvents, means we need to provide proper earthing. In this drawing, we can easily notice that the earthing is given properly. Through this manner only we can provide earthing, then we can establish safer atmosphere. Bodily, any charge that developed during the operation, we need to dissipate the charge through touching pad. This touching pad will easily dissipate the charge, bodily charge to the ground, that the person is standing on the pad, and bodily charge has to be easily dissipated through this touch pad. Every person engaging in that work initially need to dissipate the charge, then only the person is allowed to work inside the plant. Then we see how we can provide earthing properly. That is earthing. Earth pit has to be properly made and it has to be maintained properly. That is the most important. Earth pit has to be maintained properly. Otherwise, it will not conduct charges. We will see one by one. The earth pit to be maintained properly, the termination of earthing lines to be ensure full tightness. and rusting of bolt should be avoided, and cable should be properly maintained without any damages, and static earth fit resistance should be maintained below 1 ohms. Normally, every 6 months once we need to check the resistance of the earth pit, and weekly once we need to check all the connections, and static earth pit should not combine with electrical earth pit. This is the most important. If you are providing earth pit for static application, it has to be separated from the electrical earth pit. That is, we are giving earth pit, that is earthing to the motors and rotating equipment, the electric part. That electrical earth pit should not combine with static earth pit. Static earth pit, all static earth pit has to be looped together to increase the conductivity. Otherwise, if you are connecting static earth pit to the electrical earth pit, it leads to risk in this operation. So you should not connect static earth pit to electrical earth pit. These are all the standards, highest standards for static electricity. This is a standard. IS 7689 1989 is a guide control undesirable static electricity. How to control the static electricity? There is a standard. That is one more thing for code of practice of earthing. The IS standard is there. You can take this IS standard as per the guideline given in IS standard. You should maintain the earth pit and also understand the static electricity for safer operation. The code of personal protective equipment, that is footwear, anti-static shoes. This is the code. You can see that IS standard. Accordingly, you can plan your PPEs. Think safely, be productive. Safety is nothing but common sense with the presence of mind. If you are going to start any operation with the solvent, you please think of all these things, how to establish safe environment by doing any protective method. Already I given this session tips, many tips we discussed in this session. You practice that for maintaining safe atmosphere.